Okay, so at least it's using this. Is it super zoomed in also? It looks kind of normal, doesn't it? Maybe this is just zoomed in, like just my view. Okay, so I can kind of see both things here, just in case I needed to see this or something. Okay. So we're going to do the review, okay? Because the exam 3 is on Monday, November 2nd, the day after my middle son's birthday. Well, there's an algorithm that we use to determine how many problems and what kind of problems to put on an exam. I don't know if I told it to y'all before or not, but what we do is we take the exam ourselves and then we multiply everything by 3, like our time. We multiply our time by 3. And whatever we end up getting, that's whenever you're like the ideal student. You know what I mean? Like the one who sometimes you question why they're even in the class because, like, man, they really get it. You know, that's when that student's supposed to be done. And then the difference allows for everyone else to finish the exam. And the time I got was 15 minutes. So that would leave like 35 minutes just to like check your work, make sure everything's okay. Hopefully no one would like freak out or anything over the amount of time given to take this exam. I think you'll notice whenever we do the review that it's pretty straightforward. Okay. It's not gonna be like any surprises. It's gonna be exactly what we've covered, what we've gone over. The homework is always a little bit harder because I can't really control what they put in it, you know. It can get really ugly. You know, so I might cover some of the really hard problems and the other ones I'll be like, well, I think they should be able to understand it. But the review itself, I like to keep it as similar as possible to the exam. So this will be our exam 3 review. If y'all are okay with it, I was just going to talk through it, right? We've done the 50 minutes where I explain each rule and I go over why, and you know what I mean? I just want to, we can just get it done. I actually have a plan, okay? So, sorry, I didn't print these. Don't hate me. Still have to love me, kind of. Problem 1, I have it right here, okay? And it will match the PDF that I did send y'all, okay? For problem 1, the direction says to combine. Now, whenever you hear me say combine, that's add or subtract, right? Problem 1A, this is how it's written. It's open 12x cubed plus or positive 11x squared, and then minus or negative a 2x, negative 8, close, open again. I'm sorry, do a plus sign. Now open again. And inside of this set of parentheses is 8x cubed positive 3x squared and a positive 2. So if it's telling me to combine, I just look at the signs, I look at the numbers, I see what's alike, and I can combine those, right? I definitely wouldn't just combine all these numbers and then do something crazy with the exponents. Like, that's not what I was taught. But I know for a fact that if they do have the exact same variable with the exact same exponent, I can add or subtract them. That's what combine means. Exact same variable, exact same exponent, combine, add or subtract. I know what to do because of the sign. Question, usually with parentheses, if there's a negative right here, that's when we have to change all the signs, right? With this one, it's a plus sign. So I don't have to do anything except for look for what's alike. You can rewrite it without the parentheses, but you really don't have to. What we can do here is just look and find the like terms. The 12x cubed and the 8x cubed, those are alike because x cubed. Do math on their numbers, keep and keep. 12 plus 8 is 20. Keep your variable, keep your exponent. If you want, right, we're done with those. You can mark them out. Scooch on over to the next one. I got an 11x squared, and I'm looking for another 11x squared. Oh, another 11x squared, another x squared, right? I found one. So these are my two terms that are alike. They're both plus, which means they're both positive. So I just add them. I get plus 14, keep and keep, plus 14x squared. And then, because I used them, mark them out. Now, scooch on over right here. Negative 2x. I'm looking to see if I can find another term with just an x variable. And I don't see one. So I just write negative 2x. No work, like literally no work there, right? Done with that. Then right here, I have a negative 8. And right here, I have a positive 2. Neither of those have variables. They're both just constants, so they're alike. Like you can just combine them. You can add them or subtract them. When you look at the signs, that's a negative 8 and a positive 2. If you want to use your calculator, that's fine. Always put the positive number first, or you could mess up and accidentally get an error. You would do 2 minus 8, okay? Because if you do it the other way, you have to use a negative symbol, not a minus symbol, and it'll throw everything off. So 2 minus 8. The way I've taught you is signs are different. Subtract. Keep the sign of the larger, right? Their difference is 6. The biggest number is negative. What's your answer? Now let's do 1B. 1B in parentheses, it's a similar answer to this or question, is 9x squared, a negative 3x, positive 7, close, and then a minus sign or a negative sign. I'm running out of stuff. And then open. I just ran out of ink or whatever it's called. Then do a negative 2. So minus. These pencils don't like me, y'all. For me to love them, they have like 0 love for me. When? Now I'm sad. I really like writing on pencil. I have ink at home. Look at this one, how the color is. Open, negative 2, x squared. Okay, and then a negative 6x. And then a plus 4. The difference between 1A and 1B is I was adding them, so I didn't have to do anything special inside of the parentheses because this is a subtraction problem, and more importantly, it's a minus parenthesis. You have to distribute, right? Basically, you're multiplying everything by negative 1. But what I told y'all, there's nothing happening here, right? Just go and write it. What I told y'all is when you see minus a parenthesis, change all of the signs. Change all these signs. It was a negative 2x squared. Now it's a positive 2x squared. It was a negative 6x. Now it's a positive 6x. It was a positive 4. Now it's a negative 4. The negative and parenthesis, this changes signs. Okay, only what's inside of the parenthesis. Now it's just like 1A. Find the things that are alike and combine them. So if you look, 9x squared and a 2x squared, both positive. 9 plus 2 is 11. Keep and keep. And then we have a negative 3x and a positive 6x. Those are alike. Signs are different. So you subtract and you get 3. You keep the sign of the positive. I'm sorry, you keep the sign of the bigger number, which is positive. Keep and keep. I used them so they go away. 7 minus 4. That's all that says, right? 7 minus 4. 7 minus 4 is just a positive 3. That's your answer. Okay, y'all. So that was A and B for problem 1, and the direction just said to combine your finding like terms. Okay, for problem 2. And like I said, I emailed this and I wanted to print it today. I just couldn't. And so everything we do in class for the review will match that. And then like, if you want me to send it to you in a different way so you could print it, I can. Okay, so the directions for problem 2 say convert. To A. So the directions on the test would just say convert from, would convert into scientific or standard. So if it's in standard, go to scientific. If it's in scientific, go to standard, right? That's all the directions will say. So basically convert. And for A, we get 5,876, 000, 000. Teaching. WYD. Okay, so obviously this isn't in scientific notation because scientific notation had that multiplication symbol and then we had the 10 raised to a power, right? There's only 2 of these on the exam. One of each, one going to scientific, one coming out of, okay? So if I see this problem, I know that as a scientist, I don't want to write big numbers. So obviously I wouldn't be moving a decimal anywhere over here. That'd make it even larger, right? I'm going to be moving it to make it smaller. And when I move it, I'm going to count my moves, right? It is implied that it is understood with a large number, your decimals at the end. And then you move 1, 2, 3. Do not count the comma as a spot, just your zeros, just your numbers, right? And then 3, that's 4, 5, 6, 7, 8. Can I stop at 58.7? The rule was 1 between 10, right? A number between 1 and 10. So I'm going to move again. I'm going to do a really big dramatic decimal right here. That decimal now gives me the number 5.876. Because those aren't zeros, you would write those numbers, right? I would actually write 5.876. If it was just 5.8000000, you just write the 5 and the 8, okay? Just write whatever numbers are not zeros. And then this is scientific. Use your multiplication symbol, our 10. And then the way that you can think of this for your exponent is it started as a large number, right? I don't know, think about it like money. If it was 0.000000, do you want that much money? Or do you want 5876000? Like that's like millions and billions, right? You want the large amount of money. Because it started large, big, like an excessive amount, my power, my exponent is positive. Now, I don't have an example of this, but I want you to make sure you know this. Say we started with, say this is what they told me to convert, right? It's little bitty tiny. I don't want that amount of money. So my exponent's going to be negative, right? I do want this amount of money. My exponent's going to be positive. But when you go to convert this, I'm moving this way, right? Just know how to do both, how to convert either a large number or a small number. And you would literally just move until you get the same thing, a number between 1 and 10, okay? Okay, so our B has the problem 5.134, and then X, like that's our multiplication symbol, 10 to the negative 9. So a clue here, this scientific notation, my exponent's positive. And I got that from a really big, huge number, right? So if I'm starting in scientific notation and my exponent's negative, I'm going to have a really small, tiny number, right? Does that make sense? So, and that's just to let you know you wouldn't go this way. I wouldn't go this way because that's going to make that number bigger and bigger and bigger, right? In order to make a number smaller in this form, I'd need to add zeros to the front, not add zeros to the end. You want zeros at the end of your money, not the front, right? So going from scientific to standard, a negative exponent tells me that I need to go to the left. I'm going to tell you, I'm going to run out of room for my bumps, but you just start right here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. Big O decimal. And then you start filling in those zeros. Just be careful because in your mind, you're going to think, oh, I've got 9 zeros. You don't have 9 zeros because one of my moves was to get away, like to get past my 5, right? So decimal, 1, 2, 3, 4, 5, 6, 7, 8, and then the number 5, 1, 3, 4. Now, if you were told to convert a problem that looked like this, but it had a positive exponent, that's where the number gets bigger. Negative exponent, the number gets smaller, okay? They could just kind of be tricky and you could like easily mix them up. So kind of just got to make sure that you understand how to go from and to scientific and standard. Okay, so for problem 3, honestly, y'all, like, yeah, important, but not as important as our problem 3 on our review. There are 8 different exponent rules. All 8 of them are on the exam so that if in a later problem you needed to use the rule, you can use the rule. But I don't give you both sides of the equal sign. I give you the left-hand side. You have to write it in what happens when you apply it. And all of those rules almost, I want to say, it's like approximately 20 points. So it's very important, okay? It's either put all 8 rules at about 2 points each approximately, or have one problem worth 15 or 18 points. Like I'd rather have a whole bunch of little 2.5 point problems, 2 to 2.5, right? Than to have 1 or 2, 18, because there's not many problems on this exam, okay? I think there's 10. I think there's 10 in the exponent rules. Like that's all it is. Okay, so let's do these exponent rules. So it literally just says complete each rule. No idea what this view is since the stuff's all kind of messed up on the computer. Complete each rule. These won't be in the exact order that they're in, of course, because anyone could just kind of memorize, right? So they're going to kind of be jumbled. All of these problems are slightly jumbled on the exam. First rule, a to the m times a to the n. That's what it shows you. It's just that. You do not write the word product rule. Writing the word product rule gets you 0 points, but actually showing me this rule means to keep my base and add my powers. That's the complete answer. A to the m plus n, right? Because isn't that what I do when I see something like that? Now you're in a problem and you get kind of stuck later and you're like, I don't even know what rule to use. Knowing these rules, you can go back and say, oh yeah, I add them, right? You get these wrong and then you try to refer to them, everything kind of gets jumbled up. So these are very important. B, open a to the m, close, raise it again to the n. I'm hoping y'all hear me say multiply and keep and add. Right here, power to a power, multiply your powers. That's the answer when you see this on the exam. Okay, I don't want to have just the word power, nothing like that. Show me the actual thing. See? Open, A, B, close, raise it to the, I put N. Usually I like to do M, but I did N here. So I guess that's why I did N there. M or N, it does not matter. It's just something that's an exponent though, okay? Whether or not you see M or M, you should be able to solve that. This is multiple things inside of, is that better? Is it? Okay. This is multiple things inside of a parenthesis. There's no operation other than multiplication, right? I don't think I throw one in there in the exam to trick you because that just doesn't make any sense. But remember, you can't ever apply this rule unless it's multiplication. You got terms, however many, inside of parentheses, all being raised to a power. So individually, each of them get raised to a power. Again, I think in the notes, I usually use M. On an exam, I might use M. It's the same format. It's the same process. Okay. D. Okay, so this is like in a fractional form, right? We got A to the M over A to the N. So look, rule A, multiplying, keep and add. Rule B, power to a power, multiply your powers. Rule C, multiple things raised to a power, everything gets that power. Rule D, I've got something raised to a power divided by something else. That would be a quotient rule, right? The answer to this little division problem is going to be a quotient rule. When you divide, you keep, and you subtract. E. A to the 0. But everything raised to the 0 power is just 1. That's your answer. F and G are very, very similar, y'all. F, I have A to the negative M. But I know for a fact a correct answer will never have a negative exponent, right? So I know that's not in the correct form. It's not written as a fraction. So what I do is like I write it as a fraction. I bring this down to the denominator, my A. When I move it, right? When I move like from the top to the bottom or I change positions, the actual sign on my exponent changes. It's negative up here, it becomes positive down here. And what I mean by that is because everything, right? Every number, everything in the world can be written over 1. So that's what I mean by it's in the top, right? It's not in fractional form. You change the exponent sign by putting it in fractional form. Okay, G. And then I'm going to have to probably change. I might be able to do H here. It's just going to kind of go a little wonky. H, say I have 1 over A to the M. Do you see how F and G are a lot alike, right? I started with A to the M. I brought it to the denominator. That M became positive. So it was A to the negative M. Now, if you look at G, it's in fractional form. I'm going to pull it out of the bottom and move it to the top. Okay, so anytime you move anything from top to bottom, the sign changes. So this just becomes a regular plain old A to the M. And then my H is going to kind of be here because I went apparently in like a weird shape. In parentheses, A over B, close. This is more like it. Usually I use M if there's just one exponent. So raise it to the mth power. This is very similar to C, right? Multiple things, all raised to a power, everything gets the power. Here I just have some stuff up top, some stuff on the bottom. It's in a fraction form. Everything on the top, everything on the bottom. They all get the power. Whatever the power is, they get it. Even if there's more than one term, which that's what you'll see more than likely, is an X, Y, and Z over a X and a Y, and all raised to something. Each individual thing will get raised to that power. Sorry, for some reason I stopped doing that. So these are 2 points each. You got 2, 4, 6, 8, 10, 12, 14, 16. That's almost 2 whole letter grades. Okay. Using these will help you with the rest of it. And again, like I said, is either that or have a problem. Actually, it would be multiple problems being almost 2 letter grades because they're already going to be 8-ish points. Now I've got to put more weight on them, you know? So that's problem 1, 2, and 3. Combine, convert, complete. So far, those have been our directions, right? So problem 4, in our review, the directions just say simplify. It'd be too hard for each, because I've got A, B, C, and D, right? It'd be too hard to explain all the different rules for each problem that's going to be used and have that for your directions, right? That'd probably be really confusing. But if I just say simplify, when you look at a problem, you need to know there's a bunch of stuff going on here. Start applying all of your rules that you can, okay? So simplify. I wish this pen was like thicker. For A, okay, so it's in a fractional form and it's going to have parentheses around it. Similar to that. In my numerator, I have 3x to the 5th. In my denominator, I have 4y to the negative 4. And then this whole thing is being set. I'm sorry, why I say set, it's being raised to the second power. It's being squared. Why? I mean, is there a reason? Freeze would just freeze. I want to zoom in. I hit the freeze button. That's what that meant. Go slower. Please go slower. I beg you. Take your time. Hopefully that might help a little bit. Okay, so what do I notice here? I notice that I have multiple terms in a numerator, right? In the top, I have multiple terms in the denominator. That's in the bottom. And it's all being raised to a power. So that's my rule H, right? A over B raised to the M. That rule doesn't mean only one ever, like that's all you ever see is one term. It's just saying that you've got different things. That rule said that everything in the top and everything in the bottom got the power. So literally, individually, each separate term is going to get this power. I'm going to move to the right, okay? And then, actually, let me move down, and then I'll probably move up and then down again if I need to. So I'm going to move right here. I know everything needs to get that power. So I'm going to write 3, and I'm going to square it. 3 raised to the second power. That's this term getting that power. Then I scoot over to the other term, which is x to the 5th. Because it already has a power and I'm going to be raising it to another power, use parentheses. Because if you don't, it accidentally looks like 52, and that's not right. Do open x to the 5th, close, and then square it. Over, was it 4? Yeah, it was 4. Okay. I don't know how. I think I'd written 9, which, I mean, it doesn't matter. Not 9. I'd written 3. Okay, so now we take, these are 2 individual terms, right? You look at coefficients, you look at your x's, you look at your y's, you look at your z's, you look at whatever you have, all separately. 4 is going to get squared. That y to the negative 4th is going to get squared, okay? Because it already has an exponent, I put it in parentheses. I'm going to come up right here. And I'm looking at still each of these individually. What can I do? How can I evaluate them? 3 squared. That's just 3 times 3, right? That's 9. Okay, right here, what do I have? Power to a power? That's rule B. Power to a power, the answer to that was multiply your powers. So you keep your 9. 5 times 2 is 10. And that's going to be over, what's 4 squared? 16. Look right here. Power to a power, multiply your powers. You keep your y. 4 times 2 is 8. Signs are different, so it's negative. Am I done? I know that a correct answer will never have a negative exponent. So I know I'm not done. I've got at least one more step that I need to do. Okay. So if you look here, 9 divided by 16, that actually can't happen. 9 is 1, 3, and 9. 16 is 1, 2, 4, 16. Like they don't have common, there's nothing in common. So they're just 9 over 16. So, but I'm going to look at my top first, then I'm going to look at my bottom. My top is 9, x to the 10th. That's positive. Okay, it can stay. If I look at my bottom, I got 16. That can't reduce, so I've got 16. My y, can that stay in the bottom and still be negative for it to be a correct answer? No, this literally has to move up. So you just bring it up. You write y, and instead of a -8, now it's a +8. And that's your final answer. Okay. So we have a 4B. And my 4B, I have it in parentheses on here, but I really don't know why, because you don't need them. So I'm just not going to write them here. It's 36x cubed over 18x to the 8th. I'm going to actually go to the right, y'all. So when I first initially look at this problem, what I notice is that it is similar to, and we'll use the rule that we have for D, right? I've got a to the m divided by a to the n. That's saying you have something that has the same base. You have the same variable. 3 and 18, those are just numbers. 36 and 18, those are just numbers. If I can do math there, I will. But as far as the exponent rules are concerned, I know that I can apply the quotient rule because these are the exact same base. So if you actually do 36 over 18, wouldn't that just divide equally into 2? Right? 18 times 18 is 18 times 18. 18 times 2 is 36. So, and you could use your calculator, do 36 divided by 18, you get 2. This is where I can really apply the rules right here. X cubed divided by x to the 8th. My rule says that my m is up top, right? And my n is in the bottom. And when I apply the rule, I keep my base and I do top exponent minus bottom exponent. Okay, and do you see how that's kind of written up top? It's not written in a fraction, it's written up top, right? You can evaluate it in the numerator. So what you can do though is just keep your base and subtract 3 minus 8. So 2 is 2. Okay, 3 minus 8, right? Use your calculator, always put the positive number in front. This is with the positive number in front. Calculator is going to tell you -5, right? Why'd I do that? There's an X there, y'all. And that's because those signs are different and we keep the sign of the larger. My -5 is kind of written right over here because I got ahead of myself and I wrote it first. But this -5 can't stay where it is, right? It needs to move. And since it's up top, what you have to do is bring it down to the bottom. And so that would be your final answer. That x to the -5th looks a little crazy though because of, here we go, y'all. 2 to the 2 times x, 3 minus 8. 3 minus 8 is a -5. And then that has to be moved down. So you get this right here. Okay. That just looks kind of weird. Okay. So our C on this problem is also, if you do like print this or look at the review, I have parentheses and I don't really need them here. So I'm just going to erase them. Its numerator is 12, x to the 9th, y to the 6th over 6. There we go. X to the 8th, y to the 6th. I'm going to do this 2 ways. I'm going to do this in a, this is how you do it. And then I'm going to do this in a, this is why it worked. Y'all, if you do 12 divided by 6, what do you do? Like, what do you get? Just 2. Yeah, 12. Yeah, 6 goes into 12 2 times. And then look, let me apply the exponent rule. x to the 9th divided by x to the 8th. When you divide variables, you keep and you subtract. 9 minus 8 is 1. Y to the 6th divided by y to the 6th, exact same thing. Don't they just cancel? They go away. Technically, they go to 1, but you can think of it because it's all multiplication. Oh, like those canceled each other. That's it. That's your answer. If you're not there yet, it's okay. We also have 12 divided by 6 is 2. X to the 9th divided by x to the 8th is x to the 9 minus 8. Y to the 6th divided by y to the 6th is y to the, keep your base, right? Subtract your powers. And then what I get here is 2, 9 minus 8. Well, that's just 1. 6 minus 6. Well, 6 minus 6 is 0. But anything raised to the 0 power is just 1, right? That's that rule E. So because this becomes y to the 0, but I know that equals 1, you just write 2x. You could write 2x and then like times 1, but it doesn't change it. There's no reason to, okay? So do you see how knowing the rules can really eliminate a whole bunch of like little work on the side? So if you trust yourself, use them. If not, at least know them well enough to be able to break questions apart to answer it. Okay, we have a D. This is one that honestly doesn't even look that crazy. I think I went like really crazy one year. And I like put like 4 sets of parentheses and all kinds of stuff in it. But if you know this rule, like the problem actually simplifies with very few steps into this like way easier problem. Say we have this in parentheses. It's not a fraction. Okay, it's just going to be right here. 4, 9, 0, 6, 4,906, y to the 6th, z to the 36th, close, raised to the 0 power. Trey, what does that equal? 1. 1. This could be worth 4, 5, 6, 7, 8 points because literally you need to know the rules to know. I've had some very interesting math made up and attempted because they don't like, there wasn't really like the confidence there needed. And so some things did start getting messed with in a problem like this. But the only thing I want you to know is if you know one rule, at least know everything. If it's ever raised to 0 is 1. Now, if there was a little negative sign here, this would become 1 and then, oh, there's the negative. I'm not even going to throw that into it. It's just identify this big, huge, crazy thing. Oh, but wait, it's raised to the 0, so it's 1. I think I had something, and I'm going to do scribbles, but it was like something with a bunch of different variables, and maybe it was being squared, right? So there was work here. And then this, and it was also being squared. And then this, and it was to the 0, and then this, and it was to the 0. And I mean, you mark those 2 out, you've got a lot less work. You see what I'm saying? Yeah, it's not on your exam. There's one where it literally is plain and dry, very clear, recognize it's raised to the 0 power, okay? So for Friday, what I wanted to do was just cover the whole review and tell y'all you don't have to come on Friday. But we have, hold on, let me close all of this down.